Hi guys, just a quick video to show you a few of the integral techniques that we're doing tomorrow after we do some more reduction formulae. So the first one is, and it's all about definite integrals, and it's all about area. So the first one is this, that if you reverse the limits on the integral, you negate the integral. And the reason is because if you know how to integrate it, which we normally would, this would be f of b minus f of a, right? This one here. Whereas this one here would now be minus f of a minus f of b, which obviously, well, fairly obviously are the same when you put the minus sign through. Technique 1. Technique 2 says if I've got an odd function, oops. So any odd function, so let's draw one. I don't know, go for the cubic kind of thing. And if I then take the integral from minus a to a, where a doesn't matter, of fx, so the idea is then you think about it as an area. So let's just take a minus a. So I've got the area under here, area above here, and if I was a better drawer and they were perfectly symmetric, you would see that the area above the curve is the same as the area below the curve, and so it's 0. The next one says for an even function, if I do exactly the same thing, right, so any old even function, something like that, I'll take area there, and add them together. The idea is that the two areas separately are exactly the same, and so I can just take double 0 to a of the integral, which is handy. At the very least, it makes substitution at the end easier. The last one that I'm just going to write down, and then I'll explain why, is that the integral from 0 to a of fx dx is the same as the integral from 0 to a of fa minus x dx. And the way to prove that, we'll talk about what it means geometrically tomorrow, but it's not all that instructive. The way to prove it is here, is to replace x with a minus u, okay, and then I do derivatives, and I do limits, and I get that it equals the integral from a to 0 of fa minus u du with a negative, and then I use this first relationship here to change the integral to 0 to a of positive fa minus u, and then I just, instead of writing u, write x, and I'm finished. Okay, and you'll see them in action tomorrow. This last one especially is good for trig, but they're all good for trig, and you let, normally a would be pi on 2 there, because you know that sine pi on 2 minus x is cos pi on 2, and things like that. Alright, I'll see you tomorrow.